Hi students, in this class we will discuss question number 1 from exercise 10C of the chapter Electromagnetism. This first question deals with electromagnetic induction. A detailed explanation on this electromagnetic induction has been uploaded and the link is provided in the description box. The question consists of two parts. A part is what is electromagnetic induction. B part, describe one experiment to demonstrate the phenomenon of electromagnetic induction. What is electromagnetic induction? Whenever there is a change in the number of magnetic field lines linked with the conductor, an electromotive force is developed between the ends of the conductor, which lasts as long as there is a change in the number of magnetic field lines through the conductor. This phenomenon is called the electromagnetic induction. Please remember that only when there is a change in the magnetic flux, the induced current is produced. Please watch the video on electromagnetic induction. B part is the demonstration of the phenomenon of electromagnetic induction. For that, the experiment is wind an insulated copper wire. This is the insulated copper wire in the form of a spiral on a paper or wooden cylinder so as to form a coil in the form of a solenoid. Connect this to a center zero galvanometer. Between the two ends of the solenoid, a galvanometer is connected. Then place a magnet Ns at some distance along the axis of the solenoid as shown in the figure. This is the experimental setup to demonstrate the phenomenon of electromagnetic induction. This is the diagram. The solenoid is connected to the galvanometer. In the first case, the magnet is stationary. When the magnet is stationary, there is no deflection in the galvanometer. In the figure B, this magnet is moved towards the solenoid. When the magnet is moved towards the solenoid, there is motion. Therefore, magnetic flux is changing and electric current is induced in the coil, and this current will deflect the needle towards right. There is a deflection shown in the galvanometer when the magnet is moved towards the solenoid. In figure C, the magnet is again stationary. It is not moving. Therefore, the galvanometer is not showing any deflection, which means that when the magnet is stationary, there is no induced current and no deflection on the galvanometer. In this diagram, the bar magnet is moving in the opposite direction. Then the current flows in the opposite direction and the galvanometer will deflect in the opposite direction. What is the diagram E representing? In diagram E, diagram E is similar to B. In both cases, the magnet is moved towards the solenoid. But here in diagram E, this is the south pole. In diagram B, this is the north pole. When south pole is towards the solenoid, you must understand the current is deflecting in the opposite direction. Here it was deflecting towards right, but here when it is the south pole facing the solenoid, the galvanometer is deflecting in the opposite direction. You must first of all understand only when there is a change in the motion or movement of the magnet or the solenoid, there will be change in the magnetic flux, and only when there is change in the magnetic flux, an induced current is produced. What are the observations of this experiment? The first one, when the magnet is stationary, there is no deflection in the galvanometer. When there is no deflection, its pointer reads 0. Look at figure A. Second case, when the magnet with its north pole facing the solenoid is moved towards it, the galvanometer shows a deflection towards right, showing that the current flows in the solenoid in the direction as shown in the diagram B. The third observation is, as the motion of the magnet is stopped, the pointer of the galvanometer comes to 0 position. That is figure C. This shows that the current in the solenoid flows as long as the magnet is in moving. What is fourth observation? If the magnet is moved away from the solenoid, the pointer of the galvanometer deflects towards left, showing that the current in the solenoid flows again, but now in the direction which is opposite to that as shown in figure B. Current becomes 0 as soon as the magnet stops. 5. 5. If the same action, that means movement of the magnet, is done rapidly, the deflection in the galvanometer is more than before because the movement is rapid, although the direction of the deflection remains the same. It shows that now more current flows. For this the diagram is not shown. Okay. For sixth observation, if the magnet is brought towards the solenoid by keeping its south pole towards it, the pointer of the galvanometer deflects towards left as shown in that diagram. That the current in solenoid flows in the direction which is opposite to that shown in figure B. You can also watch question number 16 from the same exercise 10C, for better understanding. If you found this video useful, please share it with your friends. Thank you.